press the bell icon on the YouTube app and never miss another update.
Small important definition: even function, odd function. Okay. First, let us consider f of x is equal to x to the power of 4. Now find f of minus x. F of minus x is what? Instead of x, just you put minus x. So whole to the power of same, it is minus x. So therefore, whenever this is even power. So therefore, what does it mean? Minus x into minus x into minus x into minus x. Base minus x. Power 4 means base 4 times we have to multiply. So therefore, minus into minus plus, plus into minus, minus into minus plus. So plus x to the x to the power of 4. Alright, we are getting again f of x. So therefore here f of minus x is equal to f of x. This kind of functions are said to be even functions. F of x is called as, then f of x is called as even function. Similarly, you can establish so many kinds of even functions. Do at your home. Next, let us consider f of x equal to x to the power of 7. Remember, this is odd number. So therefore, let us consider or let us find f of minus x equal to minus x whole to the power of 7. So therefore, we have to multiply 7 times like that. So it becomes x power 7. So of course it is minus f of x. So therefore, f of minus x is equal to minus f of x. This kind of function is called, then f of x is called as odd function. This is the simple definition. So therefore, if f of minus x is equal to f of x, then f of x is called even function. If f of minus x equal to minus f of x, then f of x is called an odd function. Another important definition: equality of two functions. Okay, actually if from capital A to B and Z is also from capital A to B. Here let two functions. Okay, stop. That is f of x comma z of x have the same domain, have the same domain and codomain This is the first condition. Second condition: f of x is equal to z of x. F of x value equal to z of x for all x belongs to capital A. Of course, capital A is the same domain of f of x, comma g of x. So therefore, if f of x and g of x will have the same domain and codomain, and for every value of x, both will have the same functional values, then we say that f of x is equal to z of x. Simply f equal to z. So therefore, when do we say that the two given functions are same or equal? First condition, they must have the same domain and codomain. Second condition, you can take any value of x in its domain. Of course, there will be the common domain. So let us take the value of some x value, and put in f of x and put in g of x. If both are giving the same value, then for every x belongs to capital R, then we say that two functions are same. For example is important. For example, I will define like that: f from capital R to capital R, f of x is equal to square root of f of x. Understand? And z capital R to capital R, z of x is equal to, suppose, modulus of x. Author defined like that: f of x is equal to this one, z of x is equal to this one. Now our question is f of x equal to g of x? Question mark. 1 minute. F of x. First observe, domain same, codomain same. Okay. Half of the condition is satisfied. Next we have to check this. Okay. F of x, consider f of x is equal to root of x square. Don't say like in the previous classes, 8th, 9th, 10th, sir, square root cancel, it remains x. Don't say like that. It is wrong. So perfect definition is here. It is plus x if x is greater than 0. It is minus x if x is less than 0. It is 0 if x is equal to 0. Understand? It is nothing but modulus of x definition. Understand? Okay. Modulus of x is what? G of x. So therefore f and z have the same domain and codomain. And number 1, number 2, for all x belongs to its domain, that is what? Capital R. We are having f of x equal to z of x. Therefore both functions f equal to g are same. Next another example, second example. For example, f from capital R to capital R, f of x is defined as root of x square, and f from z from capital R to capital R, z of x is equal to only x. Only x means it is identity function. Actually here f of x, okay, both are same. F of x and g of x will have the same domain and codomain. Let us consider f of x equal to root of x square, but it is plus x if x is greater than 0, minus x if x is less than 0, and that is equal to 0 if x is equal to 0. Understand? It has 3 cases. Okay, but there is no cases. It is taking as it is g of x is equal to x. Understand? Let us take one example. Here I am taking x equal to minus 1. I am taking x equal to minus 1. X equal to minus 1 means what? It is less than 0. Less than 0 means this case. So therefore f of minus 1 means function is equal to, first minus, okay, x. X is what? Minus 1. That is equal to plus 1. So therefore f of minus 1 is equal to plus 1. But z of minus 1 is what? Actually z of x is defined as x. Means if we are putting x, it will come same. So that is equal to minus 1. So therefore clearly f of minus 1 is equal to 1 and z of minus 1 is equal to minus 1. Therefore f of minus 1 is not equal to z of minus 1. So therefore f is not equal to z. Hence f and g of different functions, even if it seems to be domains same, ranges same. Understand? So this is the example for the failure case. It is the example for success case. Okay, understand? Small important definition. Let us take the example y minus x plus 2 is equal to 0. Let us consider this equation. From this equation, actually we can written as y that is equal to x minus 2. Okay, this is left hand side, this one is right hand side. Actually, it is called in mathematics y as a subject. Y as a subject. We are telling like that. Subject means it is expressed as in terms of x alone, but not y. Means it is not a function of y again. Understand? So y is equal to other than y. It is expressed as like that. Okay. Let us consider another equation. X plus y plus 6, that is equal to 0. So here we can write x equal to minus y minus 6. So it is not a function of x again. Understand? Actually, in any subject, while we are giving the definition of one word, in the definition, it should not repeat the same word in the definition. Did you understand? For example, we are giving the definition for one thing. This is. So, in the definition, again, it should not be repeated that word. Okay? In the same sense, while we are defining y, in RHS side, y should not be repeated. We should not have y terms. Understand? Similarly, x is equal to, x is not again repeated. So means what? X can be here. X can be expressed as in terms of y alone, or y can be expressed as in terms of x alone. Observe this. Okay. Next, you come here. Let us consider. Of course, actually, it is called f of x comma y that is equal to 0. In mathematics, it is represented as simply function of x comma y. Means in this function, x is there and y is there. Similarly, here also it is function of x comma y that is equal to 0. Here x is there and y is there. Next, let us consider one particular, means separate f of x comma y equal to 0 function. That is x square plus xy plus y square. Here x into x common, we can take x common, x into x plus y square is equal to 0. So that implies x into x plus y is equal to minus y square. Then x equal to minus y square divided by x plus y. Alright, we are going to define x, but in RHS side again we are getting x. So therefore, Therefore, it is not function of y alone. Means what? Means x cannot be expressed as in terms of y alone. Okay, and here you come here. Similarly, let us consider once again same equation, x square plus xy plus y square is equal to 0. Here y common, x plus y, that is equal to minus x square. So y is equal to minus x square divided by x plus y. So therefore it is not a function. It is not a function of x alone. It is not a function of x alone. Understand? So therefore y cannot be expressed as in terms of x alone. So I showed four cases. Y is expressed as in terms of x alone. Means y is here. Where is that? X can be expressed as in terms of y alone, and y can be expressed as in terms of x alone. But here x cannot express it as in terms of y, and y cannot be expressed as in terms of x alone. Understand? So therefore this kind of functions means that is the simplest form f of x comma y is equal to 0. This kind of functions are called the implicit functions. Okay, so therefore let f of x comma y is equal to 0, and if x cannot be expressed as in terms of y alone, or y cannot be expressed as in terms of x alone, then f of x comma y is equal to 0 is called as implicit function. Understand? Those the functions are not implicit functions, they are said to be explicit function. So these are called explicit function, these are called implicit function. Similarly, we can write the number of implicit functions. Another example for implicit function, 2x square plus 5xy plus 7y square is equal to 0. Anyhow, in general, it should be of the form ax square plus 2hxy plus by square, that is equal to 0. The implicit functions will be of the form, means general form, ax square plus 2hxy plus by square is equal to 0. This is a small definition, important definition. Later we use in calculus. Understand? Definition: exponential function. Exponential function. Exponential means it may be in the form a power x or e power x, like that. First we shall discuss the function y is equal to a power x. Here two cases will arise. First case, either a is greater than 1 or a is less than 1, like that. So case 1, y equal to a power x within bracket. Actually here a is positive and special case is a is greater than 1. Right. Okay. Here here f from definition, f from capital R to capital R is defined by f of x is equal to a power x, comma, where x is any real number, comma, a is positive. This is called the exponential function. This is called the exponential function. Okay. So therefore, for this domain, so it's a domain of means a power x is domain means values of x is capital R, real number set, because already we defined like that. Okay, codomain of a power x is also capital R. Next, range is equal to open interval of 0, infinity. Why? Because by putting x belongs to capital R, we should not obtain 0 for any value. Understand? That's why it should be positive. Means take a is positive. For example, let us discuss 2 power x. So put x equal to 0. Then 2 power 0 is equal to 1. Put x equal to, for example, 4. 2 power 4. It is also positive. Take negative x equal to minus 4. Then 2 power minus 4, that is equal to 1 by 2 power 4. It is also positive. What I am telling that the form a power x should not be is equal to 0 for all x belongs to capital R. That's why in the range and a power x is always greater than 0 for all x belongs to capital R. So this is the reason for range open interval of 0, infinity. Since I can write here the reason a power x should not be equal to 0 for all x belongs to capital R, and a power x is always positive for all x belongs to capital R, like that. Okay, I said domain, codomain, range of the exponential function a power x. Okay, now let us draw the graph. This everybody should know the graph of y is equal to a power x. So therefore here this is the graph, x-axis and y-axis. This is origin. This is origin. Here actually note a, for any finite value a power 0 is equal to 1, whereas a is finite, but a not equal to 0, since 0 power 0 is not equal to 1. So therefore if a is finite except 0, then a power 0 equal to 1. Generally we are saying that any finite value whole power 0, that is equal to 1. So therefore at x equal to 0 it is 1. So put x equal to 0, a power 0 1, y value 1. So y value for example 1. Next for example I am taking a greater than 1 case. I am taking y is equal to 2 power x. So x equal to 0, then y value 1. X equal to 1, then y value 2 power 1 2. X equal to 2, then y value 2 square is equal to 4. So it is increasing. 1, later it will come 2, later it will come 4, and so on like that. Means the graph will be, for example, this is x0. For x equal to 1, for x equal to 1, y equal to 2. If it is 1, then y equal to 2 means just like 2. So x equal to 1, just like that. Later x equal to 2, y is equal to 4, just like that. So the graph will become like that. The graph will become like that. So therefore it will be like that. The graph will be like that. Understand? Right. So it is increasing function. Its direction is will be like that. So a power x is an increasing function because x is increasing, y also increasing. Understand? 0, later it is 1, later it is 2, so it is going on, it is increasing. Similarly it is also increasing 1, 2, 3, 1, 2, 4, just like that. So therefore a power x is increasing function. That's why we have to put the arrow like that. Here some observations. You can ask me, sir, why should you left this graph in x dash side, means second quadrant? So let it be, it is x dash. I am telling that, for example, you come here, 2 power, for example, x tends to 2 power, or 1 minute, as I will write here, as x tends to, it is minus infinity side, minus infinity. In mathematics, tend, T-E-N-D, tends, T-E-N-D-S, tends means approaches, and its symbol is like that, arrow mark. Understand? X approaches minus infinity. As x approaches minus infinity, then y value, y will approaches to 0. How? 1 minute. Here y equal to a power x. So put x equal to minus infinity. Then it is y equal to a power minus infinity. This can be 1 divided by a power plus infinity. Actually, in indices, a power minus m is equal to 1 by a power m. It is one formula in the indices of exponents or properties of indices. So a power infinity, that is equal 1 by a power infinity is equal to infinity, but 1 by infinity is equal to 0. Thus, if x equal to minus infinity, y value 0. Therefore, x equal to minus infinity, then y is equal to 0. Okay? So, therefore, they can say that as x tends to minus infinity, y will tends to 0. Y will tends to 0. Y 0 means what? It is on x-axis, especially on x dash, negative x-axis. That's why it will be like that. Means going on and so on and so on. Lastly, at the minus infinity, it will touch to x dash axis, negative x-axis. So its full meaning or complete meaning or equal meaning will be like that. As x tends to minus infinity, then y tends to infinity. Next, x values, x equal to 3, 4, like that, and so on up to plus infinity. This is minus infinity, minus 1, like that, minus 2, and so on. It is up to minus infinity. This is positive infinity side. This will be negative infinity side. Next, if x equal to 4, 5, 6, like that, and so on, then at the same time the graph will go on like that. Means y approaches to infinity. What I am telling that, as x tends to plus infinity, then y will tends to plus infinity. How? I will show you. Y is equal to, the graph is, our function is, y is equal to a power x. Put x equal to plus infinity, then y is equal to a power infinity. whatever it is a, then a power infinity is equal to infinity. So therefore, if x equal to infinity, then y is equal to infinity. That's why as x tends to infinity, y will tends to infinity, or if x approaches to infinity, y will approaches to infinity. Like that. Infinity means y value, it is going on up to infinity, like that, a positive y axis. Okay, this is the graph of a power x. Similarly, 1 minute. Similarly, what I am telling that you can take y is equal to a power x greater than 1 case. A is greater than 1 case. Okay, y is equal to 3 power x, y equal to 4 power x, y equal to 1.2 whole power x, y equal to 4.5 whole power x, something, whereas a greater than 1. That kind of all the graphs will be of the form this one. Understand? So this is the standard form. Here we have to notice that the function y is equal to a power x, it is an increasing function, and that to be as x tends to minus infinity, y tends to 0, and as x tends to infinity, y tends to plus infinity. Its graph will be like that, and domain is capital R, codomain is capital R, and range is equal to open interval of 0, infinity. So similarly, all the points are true for y is equal to 2 power x, y is equal to 3 power x, y is equal to 4 power x, 5 power x, 6 power x, or 2.3 whole power x, because the base is positive. So therefore, when the base is positive and that to be base is greater than 1, in that case, these 3 points and 2.5 points and the graph will be the same for all. That's why a power x is the standard graph. Now we shall discuss the second case. The second case. Okay. Next, case 2. Case 2. Case 2. Y is equal to a power x. Of course, a is positive, but a is less than 1. Understand? So this is a x-axis, it is y-axis, this is origin. Now we are drawing the graph when 0 less than a less than 1. It is to be understood a is positive. Next, special case a is less than 1. Okay, I will take a is equal to 1 by 2. Then the equation becomes a power x, like that. 1 minute. For example, x equal to 0. Then y is what? 1 by 2. Already I said how to draw the graph by taking some random values and plotting them. We are getting the right graph. Okay, x equal to 0. So this is the finite number. The finite number whole power 0 except 0 is 1. So therefore, if x equal to 0, then y equal to 1. Similarly, put x equal to 1, then y is equal to 1 by 2 whole power 1, that is equal to 0.5. Okay, x equal to, let us take 2, then y is equal to 1 by 2 whole square means 1 by 4, that is equal to 0.25 will be like that, and so on. 1 minute. Put x equal to plus infinity whole to the power of infinity, that is equal to 1 by 2 power infinity, that is equal to 1 by infinity. But 1 by infinity is equal to 0. Means what? As x tends to plus infinity, then y tends to 0. Y tends to 0. But here, you come here. Here, as x tends to infinity, y tends to infinity. Here, as x tends to infinity, y tends to 0. Since a is less than 1. Right. Next, x equal to minus infinity. That implies y equal to 1 by 2 whole power minus infinity. 1 by 2 whole power infinity means it is nothing but 2 power plus infinity, that is equal to infinity. Means what? As x tends to minus infinity, then y will tends to plus infinity, since a is less than 1. And clearly we see that while x is increasing but y is decreasing, therefore it is decreasing, it is the decreasing. Hence this is a power x, y is equal to a power x is a decreasing function, decreasing function. So domain same R, next range capital codomain capital R, and range open interval of 0 comma infinity is same for a power x. Okay. Hence graph y is equal to e power x. Actually already I said about e, whereas e is approximate equal to 2.7182, 81, 82, 84 and so on. Actually we are taking mathematically e is approximate equal to just 2.7 or 1. We are considering 2 digits. That's all. Okay. anyhow e is lies between 2 to 3. Means what? E is greater than 1. So greater than 1 means you come here. Which one is greater than 1? This one, case 1. So therefore similarly e power x graph also will be like that. So therefore e power x graph will be like that. So it holds the same properties. This is x dash x means it is 0, 1, 2 and so on plus infinity. This one is -1, -2 and so on minus infinity. Okay. So here e is equal to, let us take for mathematical convenience to 2.7. So x equal to 1. The graph is, equation is e power x. X equal to 1 means y is equal to e. Next x equal to 2. Then y equal to e square. E means let us take 2.7. This is 2.7 whole square. So that is equal to 2.7 into 2.7. 7 7 is 49, 7 2 is 14, 18. Next 14, 2 2 is 4, 5, 9, 12, 7. Means 7.29. It is approximate equal to 7.29. Means as x approaches to, means as x is increasing, then y is also increasing. That's why it is also just like that increasing function. E power x is an increasing function. Same properties will holds. So as x tends to plus infinity, y will tends to plus infinity because e is greater than 1. Since e is greater than 1. Okay. Next, as x tends to minus infinity, then y tends to 0. Y tends to 0. Here domain means actually f from capital R to capital R is defined by y is equal to, means f of x, that is equal to e power x. It is also called as exponential function. Remember, this is very important. Here domain capital R, codomain, it is also capital R. Range same. For any value e power x should not be equal to 0. Therefore it is always positive, means 0 to infinity. What I am telling that y is equal to e power x is always positive for all x belongs to capital R. Positive means therefore f of x is greater than 0. Already I said if x is greater than k, then we can write x is belongs to open interval of k to infinity. Instead of k, 0 is there. Therefore f belongs to open interval of 0 comma infinity. So this is the range. So this is all about a power x graph and e power x graph. These graphs are very important. Everybody should learn by heart the graphs and domain, codomain, range and everything you by heart. Understand? Let us consider once again the exponential function y is equal to a power x. Exponential function. Exponential function. Let us consider the exponential function once again. Y is equal to a power x. So we committed with a is greater than 0. A is greater than 0. Remember. Okay. Let this a power x. 1 minute. Already we said a power x is always greater than 0 for all x belongs to capital R. I said like that. So let a power x is equal to capital M. Then according to this, this capital M must be positive. And here M should not be negative number. Remember this point. M should not be negative number. Okay. Right. Here some observations. For example, I will take 2. That is equal to, you come here, 2 power. Okay. For example, I am writing 8. So that power must be what? 3. Because 2 cubed is equal to 8. Next. Okay. I will put one question. Other than 3. Any other real number is there so that 2 power something is equal to 8? No. Therefore 3 is the unique number so that 2 power 3 that is equal to 8. Note this point. Unique. Next, let us consider another number. 2 power. So for example, I am writing 16 on the right hand side. So 2 power something. That something must be what? 2 2s are 4. 4 2s are 8. 8 2s are 16. So therefore, it should be 4. Again, same question. Is there any other number so that, means rather than 4, any other number 2 power something is equal to 16? For 16, any other power is there? No. Only 4. So therefore, 4 is the unique number so that 2 power 4 equal to 16. Okay. Another example. 1 by 2. For example, for easy way, I took 2, 3 simple numbers. So 1 by 2, 1 by 3, just like that. You can take any number. Okay. That is equal to 0.25 means 1 by 4. What is that? Unique number. It is 2. So 1 by 2 whole square means 1 by 4. 1 by 4 means 0.4. 0.25. Therefore 2 is the unique number so that 2 power, I mean 1 by 2 whole power 2 that is equal to 1 by 4 means 0.25. Okay. We can write so many numbers like that. Right. Here actually a power x means it is exponent form. It is exponent form. Here a is called base. X is called exponent.